Okay, so it's last tutorial. It's about the ADF framework, the Agent Development Framework. Uh, if I think I should have placed the Python at the last one, since it looks like the Python attracts most of the attention. And now that everybody attended the Python, we don't have many people attending this one. But well, it's a good. I will go through the tutorial, trying to highlight some of the peculiarities of the ADF and it how we can implement a team code for the rescue simulation using it. So the agenda for today is I will provide a brief introduction about ADF, how why it why it was developed, and the reasons behind it, and then what are the characteristics of this framework with regarding or in comparison with the tempo agent API or the normal Java or Python API that is has been presented in the two previous tutorials. Then I will talk a little bit how to install and run this tempo agent using the using ADF. I will go and explain the different modules that we have in the ADF, how to configure the ADF accordingly, and try to go a little bit deeper into the code to show how the tactics work. Okay, so the introduction, the Agent Development Framework is a modular agent development framework that was developed basically to facilitate the development of teams of agents for the rescue simulation. Okay. As we saw on the first tutorial today, using the Java code, we would need to develop everything from scratch with a very few help for modules to support our development. So the ADF, the main idea was first to be a facilitator, and second to be a modular component where we could plug and play different modules performing different tasks required by the rescue simulator. So if we were interested in rescuing civilians but not into extinguishing fires, we could develop modules that were specific for that. If we wanted to study how different clusterings would impact in the rescuing of civilians, we could develop different clustering modules and replace it modularly much easier than if we had the old API, Java API alone. So this was the main motivation. And the ADF was developed by Shunki Takami from the University of Tsukuda Aichi Institute of Technology in Japan, and it was supervised by Nobuhiro at this point. I'm not sure if Kazunori was also one of his advisors, but I'm quite sure that Nobuhiro was his advisor. And then the project was transferred after he finished the development. He kindly transferred the project to the RoboCup Rescue Agent Simulation Working Group, and it's been under our ownership since October 2017. But Shunki continues to sporadically contribute to the project whenever he has some time and when we need some help. The ADF is structured into repositories. We have the core repository, which is the ADF core Java, and we have ADF Tempo Agent Java. Basically, the ADF core Java defines the ADF modules and their interfaces, and provides some default implementation to the modules interface that was provided in the core. Okay. The ADF sample agent Java, in the other hand, implements a real team of agents that can be run and connect to the rescue simulator. Okay, so the ADF sample agent Java it replaced some of the modules from the default implementation that was provided in the ADF core Java, and also implements the strategies of the agent. Well, at this point, everybody should know how to install the simulator, and it should have the simulator installed and running in their computer. So if you don't have it by now, you should look at the previous in this slides of the introduction to Robocop Rescue. And here we are going to focus on the installation and execution of the ADF sample agent. Like in the other project, we also have some prerequisites. For the installation, we have a prerequisite for Git, OpenJDK Java 17. It must be a version 17, and Gradle. And we will, to download, you can use git clone to clone the repository that is in our GitHub. You don't need to clone the core because the ADF sample already downloads automatically the core and embeds it into its source code, into the as necessary or a dependent library. To compile the ADF sample agents, it's simple. After you clone, you simply enter in the subdirectory and then enter the Gradle W clean build. The folder structure for the ADF is the following. So the build that has the Java classes, the config folder where we have the configuration files. We will go through some of the configuration files later. Docs with the documentation, lib with additional library, usually, not usually, in the GitHub repository, we don't have the lib folder because we don't have any additional library other than the ones that are specified in the Gradle dependency. But if your team uses additional library, Java library, it should reside into this subdirectory. All the logs are stored in the logs folder, and when we run the pre-computation phase, the data is stored in the pre-comp_data folder. All the ADF is open source project, so the source code is available under the some license. I don't remember right now which license is it, but you can reuse it as basically you want. Well, to run the sample agent, we need to first run the simulator. As we saw in the introduction to the rescue simulation today, we can run the simulator using the start.sh script. Once you run the simulator and you have it up and waiting for the agent to connect, then you can enter the subdirectory of the ADF sample agent and launch the sample agent using this launch.sh -all. When you do this, all the agents are connected and you will be able to run the simulator. At this point, I would suggest you to install the simulator and the ADF sample agent and try to run it in the default code scenario. I think you already have it in your computer, the simulator server. So instead of asking you to run, I will run myself just to show what happens after you install. config. So this command runs the simulation server. Once you have the server running, then we can go. I'm already in the ADF sample agent directory. We can go and use the launch.sh to run. As you can see, if we don't pass any parameter, we do have here a list of options that we can use to run. We want to run using -all because it will connect all the required rescue simulation agents to the server. By doing this, it will connect. Well, it's connecting. As you can see here, slowly it is connecting. It's slow because it calculates the clustering for each one of the agents that it's connecting. So it takes some time to process clustering. But it's going to finish in 1 more minute. Yeah, once it's finished connecting, then we can run the simulation server. And if I'm lucky, I can find the viewer again. And we can follow the simulation run with the ADF. Okay. No big mystery, it's just download and install. Kazunori, do you want some time to install it, or do you have it installed on your computer? Dina?
So sorry, what do you say?
Yeah, do you have the ADF installed on your computer? Do you want some time to install it? To try?
I've already installed. I'm now trying to run now.
Oh, okay, great. Thank you. Let me know if you have any problem, and if you don't have any problem, let me know. If you are successful, then we can continue with the sorry, with the slide. I'm sorry, it's not well yet.
Okay, Luis, I can run
Yep.
correctly.
You have run successfully? Yeah.
Yeah.
Oh, okay. So I will continue the presentation. Okay.
Yeah. I'm okay, but the other participant is okay.
Well, yeah, I think there is just Dina. I don't know, Dina, if she is. It's kind of a private lesson today.
Yeah, I think it's okay. You can go ahead.
All right. Okay. So, well, if you have any problems, then let me know. I can try. But up to now, it's kind of just installing using the clone, git clone, and the Gradle. What I wanted to enter into the structure of the ADF framework, because it is a little bit different than the Java API or the Python API, where you have just an API and you call the commands and you implement all the functionality, all the behavior of the agent. With the ADF, many things comes embedded into the framework, so you don't need to implement many things that you would need to implement if you were using the Java or Python API. And as I said, well, I didn't say this, but even the ADF core, it's split into different packages. One of the packages is the ADF.core, which that defines the extensible modules that we can implement for our team of agents. And it also implements the main functions or functionality of the ADF. So how the different modules are called, with which sequence, and things like that. And there is a second package, which is the ADF imp, which provides some default implementation of the extensible modules. For Kazunori that may have a previous understanding or knew a little bit about the ADF, we have made, in this last year, we have made a change, and we separated what is core from what is an implementation of the core. In the core, we kept only the essential interfaces for the modules, and anything that is an implementation of those modules, we moved it into the ADF input. I have been talking about module and modularity, and the ADF allows us to define different types of modules. Modules for general algorithms like path planning and clustering that are usually very helpful in the rescue simulation. But it does also provide some specific modules for the behavior of the agent. For instance, for the search, so how the agent will look for something in the environment. Detector, how the agent detects that something is available to perform some activity. Target allocator, in order to detect which targets are available for solving the problem. Like if I'm an ambulance, I can look for civilians that are buried, so I can rescue the civilians and transport them to the rescue. And the selector, which is a module that defines how I will select one of these targets. Okay. There's also some other tactical algorithms for the behavior of the platoon and center agent, which we call tactics, that we don't change, but I will try to cover today. The implementation of these modules require extending the ADF core module classes. So when I say core module classes are the ones that we define in the ADF core, we extend them and implement like in the ADF imp or in your own team of agents. So if we look more into detail, the components or modules that we have available in the in the ADF are listed down below. So this one is the path to the modules, and then we have the path planning, dynamic clustering, static clustering. These are the three different modules that we can customize for our specific needs, and we will see in the next slide how we can do that. The other types, the detector, selector, target allocator, and search, can be implemented by extending the ADF code component module complex. The complex name and algorithm is too generic, and the complex is not very self-explanatory. But well, that is the way the code is structured today. And this is part of the core. Oh, there is a mistake here. I just noticed that it should be core instead of code in this two lines. Well, for each one of these elements, the core repository has a default implementation. For instance, on the right here, we have a default implementation of the static clustering for the k-means. So the k-means clustering implementation must extend the static clustering, and inside of this class is where we implement the k-means. So it must always implement some of the classes or one of the classes that is defined in the core part. Well, we will see it later. If a module is not specified in the ADF configuration, ADF uses the default. Well, we will go into these details later. Let's get into a little bit more detail about the clustering, for instance. I said that we had the implementation of the k-means as the default implementation for the static clustering. If we wanted to implement a new clustering algorithm, we would again need to extend the static clustering. And when we extend the static clustering, there are a few methods that must be implemented that are abstract. They are get cluster number, get cluster index, get cluster entity, get cluster entities, and get cluster entity IDs. So these are the methods that we must implement when we try to implement a clustering, a static clustering. The get cluster number, it returns the number of should return the number of clusters that was generated by the static cluster method. The get cluster index, passing an entity as a reference, return the index, the number of the cluster that contains the entity that you pass as a parameter. Get cluster entity, the same, returns the index for an entity ID. So here you pass the entity, and here you pass the ID of the entity, but both will return an index of that of the cluster that contains the entity you are passing as parameters here. There's other two methods that will return not the cluster, but will return the entities that is contained by a cluster. So get cluster entity, and then the index. The index must be a number of one of the clusters that exist, and then it will return all the entities that is contained on that cluster. And the other one is get cluster entity ID, that return also just the ID, entity IDs of the entities that are contained in the cluster that you pass as reference. On the right is just the static cluster abstract class and the clustering abstract class. I placed it both because the static clustering extends the clustering, and these methods are abstract and defined in the clustering abstract class. We had in the previous slide, we had a snippet of the k-means clustering that extends this static clustering. But if you need to implement any other type of clustering, if it's a k-means plus some other more dynamic, sorry, not dynamic, but more elaborate clustering method, you can do that by extending the static cluster. To implement other elements of the ADF core, you can extend the abstract class that is defined in the core and then implement their method, their abstract method. For instance, if you want to implement a new build detector, which is a component that is used by the ADF to find some building in the perception of the agent or in the area, you should extend. Again, here there is a mistake. It should be building detector and not build detector. I will make the change later and redeploy the slide. And we must implement the method called calc. So the calc here will calculate or will define which are the buildings that I detect, and observe that the calc returns the building detector itself, because then it's used by the ADF to retrieve the building through another method. Let's see the default building detector. Again, here I forgot the gerundio, the building detector. So the default building detector is implemented under the ADF implementation, and it extends the building detector as it should be. And as you can see, it does have a constructor, and inside the constructor, it does have a call to a module manager to get some module, like this default building detector clustering that we'll try, we will see later. It will try to find this label in the configuration file. If it does not find, then it will use the default k-means clustering as the clustering mechanism for the for this building detector. And it also implements the calc method. And in the calc method, you can see that it does call two other methods. One is to calc and get the target in the cluster, and then calc target in the world. What these two methods does, I will not go into details here, but it first tries to find a target building in the cluster that the agent is allocated to. If it cannot find any target building, then it tries to find any building anywhere in the world, in the environment. If it cannot find, then it's null, but usually you will find and will return it to the agent. Observe it again that the calc here does not return the building in itself. It returns the building detector, and then the agent, the ADF can extract the building that was detected later on. So here is the default implementation of the build detector. If we want to change it, we can, again, create a different class. In this example here is the simple building detector class that extends the building detection. And well, we keep the same module manager for the cluster. And we keep also the same sequence for the detection of a building. But in the sample, or I forgot to, sorry. Oh, I was looking at the wrong slide. We keep the same clustering method as in the default, but we changed the way the calc is implemented. So now instead of getting a target first from the cluster and later from the world, it does not care if there is a clustering system or not, and selects a target randomly from the whole environment using this line of code. Okay, so it's an implementation of the build detector, but it's different than the default implementation. Okay. So now we have already, so we saw that there are different modules that we can implement. One of them is the building detector. The building detector has the API, the class building detector, that needs to be implemented or instantiated. And we have it implemented in two different ways. One is the default build detector, which is implemented inside the ADF core repository. And the other one, the sample building detector, that is implemented into the sample agent repository. Sorry. Well, now we need to define how can we specify which one of these two build detectors that my agent team will use. In order to do that, we have several configuration files. Before we go into the more interesting configuration file for the modules, let's first look at the launch.tfg. This is a general configuration file that defines which are the server that the agent team will connect. If there is going to have a pre-computation, if we are going to be in a debug mode and in a develop mode, and which is the module configuration file that will be used to load the different modules or the different parts of the ADF. And the last part is the number of each type of agent that will connect to the server. Basically, the server connect is defined in the kernel dot host, in this case, localhost, and the port 27931. We have here also the team name that is defined, and we have the different flags, which is first the pre-compute, if there is or there is not a pre-compute. 0 means false, 1 means true. So here we are going to launch this team without pre-compute. Again, the debug flag defines whether or not the agent team will run with the flag with the debug enabled or not. The develop flag defines whether or not we'll run with the development flag enabled. And here it's set no. If it's set yes, then some of the modules of the ADF can read the contents of the develop.json file. And well, then we have the module, which is just the link. This is the general file that configures the that defines how the agent team is going to run. Then we have
Luis?
the mod. Yeah, yeah.
Luis, could you tell me about the develop mode again?
Okay, so develop flag. It's the modules when the ADF gives information to the different modules. I can show you later. It also gives some development information. It's kind of a general information that you can pass to the module when you are in a development phase. It's a little bit different than debugging, because debug you can also enable when you run the simulation. The development, the purpose of the development is to pass information while you develop the module.
Okay, I got you. And you show the later.
Yeah, I can show you now. Just 1 second.
I see the slide, and I would like to know about the develop.json, but you will explain on this slide. Yeah, thank you.
So yeah, okay, but I will keep it in mind and I will concentrate on that. So the develop, it's not something that is very common in any in other frameworks. Is usually you have just a debug flag, but you don't have a develop flag. It's also interesting for me because I was not aware, and see that it points to a separate file, develop.json file. This is it's a JSON file, so you can pass any information you want through this file to the modules, and then you can access the parameters that you give here, the value of the parameters that you give here inside of the module. I will show you how you can access it.
Okay, I got it. Thank you.
Yeah. So, but here is where you define the general characteristics of your agent team. Then you have the module.tfg. Here is just on the right, it's just a snippet of part of the module.config, because this file is huge, and if you open one of them in the real repository, you will see that there's many definitions. So here I'm focusing only on the default tactic ambulance team module, and what this module.txt does is specify the module implementation that is going to be used when you are running the team. Because the ADF is so modular, it allows you to change any part of itself, of the team code at any moment. It's in a very granular way. Okay, so first it allows you to set the name of the team, but then it allows us to define the different. Here again, there is another problem. On the first one, let me focus on the search here. Like the default tactic ambulance team.search, it assigns the package sample team module complex simple search. Okay, so when the default tactic is doing using the search method for some reason, it will use the search that is implemented in this package here, simple team module complex simple search. Later on, we will see that we can change the implementation of the search without changing anything on the ADF core. And well, I think you saw earlier the command called module manager dot get module, and it had two parameters. One were the label, and the second one was a Java class path, a path to a default module implementation. Okay, yeah. So the label that we define in the get module is the name of that. Is this one here? Is this label here? And the second parameter on the get module is the path of the default module implementation. If you forget to define in the module.tfg a content or a path to the label that the get module is trying to locate, then the get module will use the second parameter as a default. I think this is really, really confusing. So I will move to the actual implementation so you can see what I'm talking about. Okay. Here's the ADF form. And here are some of the implementations. I will get into the simple building detector. Okay. So the simple building detector, it implements or extends the building detector. Okay. And in the simple building detector, it uses clustering. So it loads dynamically one clustering that is defined, that can be defined in the config file, in the module.txt file. So here we have the, maybe I will try to increase the font size. Just 1 second, let me see how I do that. Can you see that?
Yeah, I can see that.
Oh, okay, nice. So inside the sample building detector, we have this module manager get module. And I'm saying, okay, look at the module.txt file, look for this label, and try to load the library or the package and the implementation that is defined there in the module.txt. If you cannot find this label in the module.txt file, then you load this implementation instead.
Okay. The first parameter is the default.
The second parameter is the default in case this label is not found in the module.tfg. I will open the module.tfg here.
Okay.
So let's try to look for sample building detector dot clustering. See? Okay, so this command will look for this in the module.tfg. In this case, look, it found, and it will use this k-means as the clustering algorithm. For the building detector. Okay, so it's gonna use the sample k-means. However, if for instance we comment this line or we delete this line altogether, the agent, the command, this module manager get module, will not find this label in the module .tfg.
Yeah.
So since it does not find, then it loads this one as a default implementation.
Okay. Yeah, I got it.
Okay.
Yeah.
Why is that? Why they implemented this way? Because if someone forgets to specify in the module.txg file the label, the team does not fail. The execution of the team does not fail. There is always a fallback implementation that can be used. This is really difficult for people to understand. And it's always difficult to specify in the module.tfg file all the different labels, because there's many modules that require different components algorithms. That's why when you look at the module TFG file, you see this huge file here.
Yeah, I know.
Yeah, and yeah, the module TFG is even longer than the one that was there. Okay, so here is how it is identified. Just to, since I'm already in the code, here is where your developed data comes in. So when the ADF loads the agent, it sends to each one of the different modules, it sends this developed data. And you can use the developed data inside your code, basically. How do you access this developed code? You use this developed data dot. Then there is different get here. The only trick is that you need to know the type of the data that you want to read. But let's say it's a double. You need first to give the name of the parameter. So where it comes from, this parameter comes from the developed JSON file. So in the developed JSON file, you have these different properties with a value in front of it, right? All of them here are integers. So let me change there. Let's say I want to get this sample building detector sending a void time clear request. So here I would have get integer Casanori. This is how you use the data that comes from the development. Actually, yeah, actually, there is one trick. There is you can set if develop data dot is develop mode, then you do this. Just a second here. What we are doing here is, okay, we check whether or not the developed flag is one.
I know.
So if the developer flag is one, then it can read the parameter from the developed JSON. The interesting thing is that this is not predefined as a JSON file, and you can define anything, put anything there, anything that you think is useful for development.
Oh, yeah. Mhm.
Okay, and it's not a debugging mode; it's a development mode, which may be different from different
Yeah.
in the eyes of the developer.
I-
And here,
yeah, I think in this case, the method name should be set to integer. I think get integer means get to the parameter.
yeah, it
Is
will get an integer because here is integer. Oh, sorry, this one.
yeah, yeah, yeah. Mm.
Here's a number, and
Okay, I got it. Yeah. Okay, okay.
yeah, so
So yeah, get from the .json file.
yes,
Yeah.
yeah, it gets the data from the JSON file, and I think you are questioning this one here, what it means.
Yeah.
This is, let's say that I put a label here that cannot
Mm-hmm.
be found in the develop a JSON,
Mm-hmm.
then the default value is one.
Oh, yeah. Okay.
It's similar to the module manager get module.
Mm. Yeah.
So it always have a fallback in case of in case something is not defined. So the
Yeah.
agent does not fail. Okay.
Okay. Yeah.
So is it clear now how it works, the module.txt? I think you already have some experience, but yeah, it's quite interesting how they implemented the ADF. Okay, so
I completely understand the development mode. Thank you.
yeah, okay. So here it's where I was going to go through the development, but we already went through. So I will skip it. And well, here I was going to ask if you want to implement the A star path planning algorithm and replace the sample path planning in the ADF sample agent by the implementation. You don't need to implement yourself. There is a code in the ADF sample in this link, which is the link to the documentation. Oh, I copied wrong. Oh, okay. I put it wrong. The link in the many errors in this slide set. Yeah. So here in this section 4.2, 4.4, 1 and 4.42, it explains how you can implement the A star algorithm and replace the path planning of the sample agent by it. Do you want to implement it, Dina Kazunori? Or yeah, because at this point in the presentation, this tutorial, I was ask everyone to, after they installed everything correctly, to follow the steps in these two subsections here.
Yeah, but today I have no time to implement because so at firstly I have to leave the within 30 minutes.
Oh, okay. So, well, so this would take a long time. I was expecting to take more than half an hour. Then I don't have many slides actually. What I have is just after people implemented that, I had the tactics. And what I wanted to say in the tactics is that the ADF already implements default tactics. And what does it mean? The tactic is a sequence of actions that are performed by the ADF using the modules that we provide the ADF using the implementation, right? So the default implementation is in the ADF implementation tactics, that's where the priority is to find a target, and the ADF implementation centralized, where it makes the centralized decision-making process. This part I was going to show the code actually. So let me cancel this.
Okay. Could you send the link to the path planning algorithm? So I can't access from the slide.
Okay. I will send in the chat the link.
Yeah.
I will fix it later, but the link is the one I sent in the chat.
Yeah. Okay. I got it. Thank you.
Yeah. So we have several implementations of the tactics. The implementations are for each one of the different types of agents, like police force, police office, fire station, fire brigade, ambulance center, ambulance team. Let's go through the police force tactic. What the tactic does is implement the think methods that will be called at every cycle of the agent reasoning. So it will initially update its beliefs. We're using some default methods. After it updates the beliefs based on what it received of information, the agent, the police force, tries to read the communication to find a target. By target, we mean a blockade to follow. And it also tries to listen to the messages to see if someone is instructing it to perform an action. So the tactic of the ADF is a centralized tactic. It's not a distributed. So it gives priority to the command that it receives from someone else, from a center, for instance. So the center command has priority over the decisions or autonomy of the agent. However, if no command is found, so if there is no command ordered by anyone, then the agent needs to perform some action, and it tries to find some action to perform. And the action is basically autonomously random in the environment. So it looks the road it's located and tries to send to find a target for a road, and then it sends an action to that target. So basically what it does is it gives priority to what is commanded from the center. If the center is not saying to the police force to perform any action, then it takes a decision and chooses a target in itself and tries to clean. In the case of the police force, it's a clean action. It tries to clean some blockage it from his own choose. If it cannot find anything, it just moves around in the environment. Okay, and for all the agents, the tactics are pretty much the same. They try to do the task that is defined by the sent by the center. If the center does not send any instruction, then they do whatever they want. They try to find their own tactics to perform action. And this is how the all the tactics for all the rescue agents are implemented here. It's implemented under the implementation tactics and also under the implementation centralized. Okay. Is there any question? Kaznuri, Dina?
Yeah, thank you so much. I understand more deeply.
Okay.
Yeah,
Yeah,
before
so
releasing the workshop. Yeah.
okay. Yeah, so this one, since I was expecting that people would implement the A-star algorithm, and I was expecting a lot of questions about the ADF when they were trying to implement that. I didn't add much more to the slide, and basically I was not expecting to cover anything else from the ADF, even though there is some more things that we could cover, but I didn't prepare anything for now.
Yeah.
Do you have any specific question you would like to clarify? Yeah, the ADF is kind of very complex.
Yeah, I knew.
Yeah, it demands a lot of checking and exploration of the code in order to be able to understand the sequence of steps that it follows. But basically, you have the tactics. The tactics are then used to trigger the target locator, the other features in the building detector, all the other modules that we dynamically define and load when we run our team of agents. The most important part to understand are the configuration files. If you understand how to fill up the configuration, especially this config module.tfg, then it's going to be okay.
Yeah, I knew. To 2080, many teams had a mistake to set the configuration files.
Oh, okay. Yeah, so you already had experience. So my take was, okay, if it's default tactic, so what we did in this restructuring of the ADF, we also put the name here as the name of the package of the class. So the default tactics ambulance team is here in the tactics. Default tactics ambulance team. So if you come here, you will find that it loads the, here's the module. So default tactics, human detector, default search, default external action transport, default external action move. And if you come back here, you will see the human detector, search, external action, external. So every time you want to know what you need to put in the module.tfg, you need to look at the modules that you want to load, look at the constructor, the initialize, sorry. In the initialize, you will have these different get modules. And then you can use this list to define what is going to come here.
Yeah. Okay.
Okay. So this is how usually I do. So the same is for the fire brigade, police force, all of them.
Yeah.
Is there any other questions?
I'm okay. Thank you so much.
Okay, Dina, any question, any comment? I don't know if she.
No, I'm good. Thanks a lot.
All right, so thank you both for staying for this second part, third tutorial. So I think I will thank you and finish the tutorial by now. I will fix the slides. I saw some mistakes, and I will release the slides again on the PDF on the website. And if you have any questions about the ADF, don't hesitate to send a message asking what may be the problem. Okay.
Yeah, okay. Will you upload the MP4? These workshops?
No, who is recording is the Maido Engineering. So
yeah, we are recording this. Yeah, we are recording this. So but it's quite a long session. So I will try to check the file, and then when I have the link of the file, then I will send it to you, Luis.
Oh, okay. So
yeah.
I can try to break it and add it, so I separate in different in different tutorials, in different sessions. Yes.
Okay.
I can do that.
Yeah, because when I got a file, then I will send the link to you. Yeah.
All right. Perfect.
Okay. Thank you so much.
Thank you very much for attention. And Ponchai, thank you for hosting us for these 3 tutorials.